Hi, all my YouTube viewers. Crystal here. I'm just here this morning to make a quick video. This is the second video that I've made because the first video didn't work out. What I wanted to do is I wanted to talk about this program I wrote. The question is going to be, can artificial intelligence predict a stroke? And it's something that is important to me because they tell me I have diabetes. And so yesterday I was just, they do tell me I have diabetes, but they also tell me I have high blood pressure. So yesterday I was just at the doctor talking to him about it, and I don't like doing it. So this is a really good question for me, since I'm at risk of having a stroke, since I have high blood pressure. And what I'm going to do is I'm going to go over this with you very quickly because I'm not sure if my screen recorder is going to work. So the first thing we do is we go through the problem statement. So I'll just leave the problem statement on the screen for you for a little while so you can read it. And then the second thing we're going to do is we're going to import our libraries of Panda, NumPy, and Seaborn. We read our libraries. It's a combination of numeric and categorical columns, and the last column tells you whether you're at risk of having a stroke or not. The test data set is very similar to that, and the sample data set just tells you what Analytics Vidhya wants to see when you submit this to their solution checker. We test for any values, any missing values, and the BMI and the smoking status, we have missing values. So that's something that's going to need to be imputed. The next thing we do is we do a graphical representation of it. So you can see that most of the examples are 0, and we have a very small amount that's 1. So it says a very small amount of people are at risk of having a stroke. Then we've got a graphical analysis of all of the columns. So if you like analyzing using graphs, we've got lots of graphs here for you to analyze. Then we count the columns. We have 98.195853% are 0, which means they're not at risk of having a stroke, and 1.804147 are 1, which means they are at risk of having a stroke. Then we define our x, y, and x test values. Y equals train.stroke, x equals train.drop, and then you drop the ID in the stroke, and x test equals test.drop ID. And the thing is we have to create a variable called ID and put test.id in that variable, because we're going to need that variable at the end of the program when we create our data frame. Now what we do is we create a column transformer, and the column transformer has a numeric and categorical transformers. The numeric features consist of the numeric columns, and the categorical features consist of categorical columns. And we have a preprocessor that has the numeric and categorical features on it. Then we split our X up for training and validation. We give a test size of 10%, and stratify equals yes, and shuffle equals true. Since Google Colab does not have CatBoost on it, what we have to do is we have to install CatBoost. We create our model with CatBoost. Its first thing that happens is it's pre-processed at our preprocessor that we made earlier, and then we set it up as a classifier. We come over here and we set the balance up. So the balance is for each example or each class is 1 minus the percentage. So I had to set that up very precisely to get as accurate prediction as I could. So we go down, and CatBoost is going through all of the iterations and telling us all of the iterations that it's going through. And so I'm just going to go down and try to get to the end of all of the iterations. And we have 99.99% accuracy, which is very good. And then the next thing that we're going to do is we're going to test on the validation set. And when we test it on the validation set, again, we had like a 97.46% accuracy, and you can see that there was a representation of the 1 values, although it didn't pick up all the 1 values that it should have picked up. Then we test on our test set, and what I had done is I had made it to where you could see the 0 and 1 values, but for some reason it didn't pick it up, and I've had problems with it before. But whenever I wrote the program, I did actually have the 0 and 1 values out there, so you could actually see that it did actually pick up some 1 values. But what happened when I put it up on the submission checker, I only had like a 50, a 51, or a 52%, which I found to be quite shocking. And the reason why I found it to be so shocking is because we had such a high degree of accuracy on our test set and our validation set that I'm not sure exactly why we didn't have a high degree of accuracy on the testing set. So I'm going to go ahead and do some more work later on, but unfortunately I'm going to have to stop this video because I'm running late and I have to go somewhere in 10 minutes. So thank you so much for watching this video. I'm going to be making a blog post on this video, and I look forward to watching that and reading it as well.